Hello, so today we're going to be reviewing PEP 3138, which is titled String Representation in Python 3000. This is part of a series that I'm going to try and do where I read all of the final PEPs. PEPs have different statuses, and one of the statuses is final. So I'm going to try and read all of them, and I suppose have some unplanned review in it as well if I feel compelled, but that might be a little bit more in other videos, but I'm definitely going to read through it. I haven't read through this before, so I might make some mistakes, and I apologize about this. I'm here trying to learn just like all of you, and so let's just jump right into this. So PEP 3138, titled String Representation in Python 3000. The author is Atsu Ishimoto. The status is final. The type was standards track. It was created on the 5th of May in 2008. And it has a post history that includes that date and also June 5th of 2008. Let's start at the abstract. Abstract. This PEP proposes a new string representation form for Python 3000. In Python prior to Python 3000, the repr built-in function converted arbitrary objects to printable ASCII strings for debugging and logging. For Python 3000, a wider range of characters based on the Unicode standard should be considered printable. Section Motivation. The current repr converts 8-bit strings to ASCII using the following algorithm. 1. Convert carriage return, line feed, tab, and slashes to /r, /n, /t, and //. 2. Convert other non-printable characters, such as 0x00 to 0x1f and 0x7f, in non-ASCII characters, such as those greater than 0x80, to /xxx. Okay, interesting. And then 3, \escape quote characters, the apostrophe, and add the quote character at the beginning and the end. For Unicode strings, the following additional conversions are done. 1. Convert leading surrogate pair characters without trailing character, which is from 0xD800 to 0xDBFF, but not followed by 0xDC00 to 0xDFFF. And you're converting those to the to this value /U_XXXX, and then you convert 16-bit characters, which are greater than 0x100 to /U_XXXX. And then you convert 21-bit characters, which are greater than 0x10000 or 0x10,000. Okay, so you convert those 21-bit characters and surrogate pair characters to /U00 and then 6 x's. Okay, this algorithm converts any string to printable ASCII, and repr is used as a handy and safe way to print strings for debugging or for logging. Although all non-ASCII characters are escaped, this does not matter when most of the string's characters are ASCII. But for other languages, such as Japanese, where most characters in a string are not ASCII, this is very inconvenient. We can use print, a Japanese string, to get a readable string, but we don't have a similar workaround for printing strings from collections, such as lists or tuples. Print list of Japanese strings uses repr to build in the string to be printed, so the resulting strings are always hex escaped. Or when open Japanese file name raises an exception, the error message is something like IO error, error number 2, no such file or directory, /U65E5, /U672C, /U8A9E, which isn't helpful. Python 3000 has a lot of nice features for non-Latin users, such as non-ASCII identifiers, so it would be helpful if Python could also progress in a similar way for printable output. Some users might be concerned that such output will mess up their console if they print binary data like images, but this is unlikely to happen in practice because bytes and strings are different types in Python 3000, so printing an image to the console won't mess it up. This issue was once discussed by Hai-Shik Chang in this reference, but was rejected. Section specification. 1. Add a new function to the Python C API with the definition as int pi underscore unicode underscore is printable, which takes a pi unicode variable called ch. This function returns 0 if repr should escape the Unicode character ch, otherwise it returns 1. Characters that should be escaped are defined in the Unicode character database as cc, which is other control, cf, other format, cs, other surrogate, co, other private use, cn, other not assigned, zl, separator line, refers to a line separator, which is /u 2028, zp, separator paragraph, which refers to a paragraph separator, which is /u 2029, zs, which is separator space, other than ASCII space /x20. Characters in this category should be escaped to avoid ambiguity. The algorithm to build repr string should be changed to convert carriage return, line feed, tab, and slashes, or I guess this is a backslash, to /r, /n, /t, and // Convert non-printable ASCII characters from 0x00 to 0x1f and 0x7f to /xxx. Convert leading surrogate pair characters without trailing character 0xd800 to 0xdbff, but not followed by 0xdc00 to 0xdfff. And you're converting these all of those things in those ranges to /u xxxx. Convert non-printable characters, pi unicode is printable, return 0, to xxx or /u xxxx or /U00 xxxxxx or 6 x's. Backslash, and then the final part of this algorithm is backslash escape quote characters, which is an apostrophe, which is 0x27 in hex, and add a quote character at the beginning and the end. So actually, whenever I was saying slash in the last 15 seconds, probably in this entire review, I actually am meaning backslash. I'll try and do that now. The next thing is set the Unicode error handler for sys.stand_error to \replace by default. Add a new function to the Python C API, which has the function definition of pi object *pi_object_ ASCII, and takes the arguments of a pi object *o, which I'm pretty sure in C that's a pointer to a pi object. This function converts any Python object to a string using pi object repr, and then hex escapes all non-ASCII characters. Pi object ASCII generates the same string as pi object repr in Python 2. Okay, then add a new built-in function, which is just ASCII. It's just a function called ASCII. This function converts any Python object to a string using the repr function, and then hex escapes all non-ASCII characters. ASCII, the function ASCII generates the same string as the function repr in Python 2. Add a %a string format operator. %a converts any Python object to a string using repr, and then hex escapes all non-ASCII characters. Then %a format operator generates the same string as %r in Python 2, as %r in Python 2. Also, add a !A conversion flags to the string format method, and add a %A operator to the pi unicode from format function. They convert any object to an ASCII string as %A string format operator. And the last one of this section is add an isPrintable method to the string type string.isPrintable, which returns false if repr would escape any character in the string and otherwise returns true. The isPrintable method calls the PyUnicode isPrintable function internally. Section Rationale. The repr in Python 3000 should be Unicode, not ASCII based, just like Python 3000 strings. Also, conversion should not be affected by local setting, because the local is not, you probably pronounce this, because the locale is not necessarily the same as the output device's locale. For example, it is common for a daemon process to be invoked in an ASCII setting, but writes UTF-8 to its log files. Also, web applications might want to report the error information in more readable form based on the HTML page's encoding. Characters not supported by the user's console could be hex escaped on printing by the Unicode coder's error handler. If the error handler of the output file is \replace, such characters are hex escaped without raising Unicode encode error. For example, if the default encoding in ASCII, print hello with this coin symbol, will print hello/x A2. If the encoding is ISO 8859-1, hello coin symbol will be printed. Okay. The default error handler for sys.standout is strict. Other applications reading the output might not understand hex escaped characters, so unsupported characters should be trapped when writing. If unsupported characters must be escaped, the error handler should be changed explicitly. Unlike sys.standout, sys.standerror doesn't raise Unicode encoding error by default, because the default error handler is \replace. So printing error messages containing non-ASCII characters to sys.standerror will not raise an exception. Also, information about uncaught exceptions, such as exception, object, or traceback, is printed by the interpreter without raising exceptions. Section Alternate Solutions. To help debugging in non-Latin languages without changing the repr function, other suggestions were made. The first being supply a tool to print lists or dictionaries. Strings to be printed for debugging are not only contained by lists or dictionaries, but also in many other types of object. File objects contain a file name in Unicode. Exception objects contain a message in Unicode. These strings should be printed in readable form when called with the function repr. It is unlikely to be possible to implement a tool to print all possible object types. The next suggestion was use sys.displayHook and sys.acceptHook. For interactive sessions, we can write hooks to restore hex escaped characters to the original characters, but these hooks are called only when printing the result of evaluating an expression entered in an interactive Python session, and don't work for the print function, for non-interactive session, or for logging.debug. The next suggestion was subclass sys.standardout and sys.standarderror. It is difficult to implement a subclass to restore hex escaped characters, since there isn't enough information left by the time it's a string to undo the escaping correctly in all cases. For example, print \+ U0041 should be printed as /U0041, not A, but there is no chance to tell file objects apart. Suggestion the last suggestion, I think it's 4. Make the encoding used by Unicode repr adjustable, and make the existing repr the default. With adjustable repr, the result of using repr is unpredictable and would make it impossible to write correct code involving repr. And if current repr is the default, when the old convention remains intact, and users may expect ASCII strings as the result of repr. Third-party applications or libraries could be confused when a custom repr function is used. Section Backwards Compatibility. Changing repr may break some existing code, especially testing code. 5 of Python's regression tests fail with this modification. If you need repr strings without non-ASCII characters, as Python 2, you can use the following function. Definition, repr ASCII, which takes an object and returns a string, returns the string of the repr of an object that's encoded as ASCII with backslash replace. Yes. And then ASCII is also sent to the string function so that it knows how to interpret the bytes from the repr of the object. For logging or for debugging, the following code can raise Unicode encode error. Log equals open log file in write mode, log.write, the representation of the data, or the repr function. And in the comments it says Unicode encode error will be raised if data contains unsupported characters. To avoid exceptions being raised, you can explicitly specify the error handler. And in this example, it shows it log equals open log file in write mode, where the errors is backslash replace. And then when you call log.write repr of data, unsupported characters will be escaped. For a console that uses a Unicode-based encoding, for example, en_us.utf8 or de_de utf8, the backslash replace trick doesn't work and all printable characters are not escaped. This will cause a problem of similarly drawing characters in Western Greek and Cyrillic languages. These languages use similar but different alphabets descended from a common ancestor and contain letters that look similar but have different character codes. For example, it is hard to distinguish Latin A, E, and O from Cyrillic A, E, and O. The visual representation, of course, very much depends on the fonts used, but usually these letters are almost indistinguishable. To avoid the problem, the user can just adjust the terminal encoding to get a result suitable for their environment. Okay, section rejected proposals. 1. Add encoding and error arguments to the built-in print function, which with defaults of sys.get file system encoding and backslash replace. Complicated to implement, and in general this is not seen as a good idea. Okay, these are the rejected proposals. So the second one was use character names to escape characters instead of hex character codes. For example, repr of /u03b1 can be converted to /n Greek small letter alpha. Using character names can be very verbose compared to hex escape. E.g. repr of /u fbf9 is converted to /n Arabic ligature uighur. Oh man, that's really weird. So there's this long alternate thing that they were considering. 3. Default error handler of sys.standout should be backslash replace. Stuff written to standard out might be consumed by another program that might misinterpret the slash escapes. For interactive sessions, it is possible to make the backslash replace error handler the default, but this may add confusion of the kind it works in interactive mode, but not when redirecting to a file. And the last section, the next section is implementation, and the author wrote a patch in this link. This was committed to Python 3.0 branch in revision 6.41.38 on the 6 on this date. And then there's the references section and the copyright section. So this has been a review, mostly just a reading of PEP 3138, a string representation in Python 3000. I'm going to continue doing more of these. If you are interested in learning more about programming, you can check out a blog that I'm currently working on at the domain name pyharbor.com. And I am probably going to have some articles that are related to PEPs and RFCs on there. Right now there's only stuff about like programming and writing certain types of different systems in Python, but I plan on adding a lot to that. And if you have any feedback about how I could improve my reviews or my reading or my articles or whatever, just leave a comment, and thanks for listening.